This graph is a graph of the second derivative of a function, and we are required to write down the intervals where the function is concave up and concave down. Okay, um, and then we need to find the x coordinates of any inflection points. Now, the first thing is this. We need to identify where the second derivative is greater than 0. Now, in these portions here of the function, the second derivative is greater than 0. Okay? So, what I'm saying here is here, the second derivative is greater than 0. The second derivative is greater than 0. Because this is a graph of the second derivative. And then below, below here, this portion here, the second derivative is less than 0. So this portion here, the second derivative is less than 0. So we can use this idea to, and by the way, you can see that at these points here, concavity changes. All right. In fact, up here, it's concave up. Okay. Up here, here the function is concave up, and here the function is concave down. So you can notice that at this point here, okay, at this point and at this point, we can notice that the second derivative is equal to 0. Okay, the second derivative is equal to 0. So these are just key things that you can actually see from this graph. The second derivative is equal to 0, and concavity changes. Okay, so the second derivative is equal to 0 and concavity changes at those 2 points. So we can go ahead and answer the questions. So which means if the second derivative is equal to 0 and concavity changes, then it means that those 2 points are the points of inflection. All right, so which means that the points of inflection are the points of inflection occur at, what's the best word, occur at x is equal to -2 and x is equal to 4. So that's the first thing that we get. Now, the intervals where the function is concave up and concave down are already shown on the diagram. So concave up, you can say concave up when the second derivative is greater than 0. And looking at the diagram, where it's greater than 0 when x is less than -2 and when x is greater than 4. Okay, so you can go ahead and say when x is less than -2 and when x is greater than 4. Concave down, concave down. When the second derivative is less than 0. And if you look in the diagram, where is the second derivative less than 0? That will be between -2 and 4. So that will be between -2 and 4.